The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian volcano update. Today is Thursday, February 10th, 2022. You guys are looking at Kilauea on a screen here, will be the main focus of our attention today, but also a little bit of Maunaloa, which had a little bit of an earthquake flurry over the weekend. Nothing major, but we'll talk about that as well. And we'll also wind up with showing you guys one of the talks from Volcano Awareness Month by Matt Patrick, which reviews the whole last decade of eruptions and eruption footage on Kilauea. So we will be taking live viewer questions and discussing that as we go along, so put those in the chat for Dane, and he'll answer what he can and collect some others for us to discuss live. Let him know if you have any issues with our video or audio as well, and we will work on that if there are any issues. Mahalo you guys for joining us today. So the volcano is doing pretty much what it has been. It's been fluctuating in how much lava comes out, more and less and more and less. But what's been different this past week has been that we've only had one pause. There have been lots of ups and downs, but only once has it stopped all the way. And so just to start off, you guys, I was showing you guys this V1 camera, last 24-hour loop from the USGS HVO. But what I'd like to do is actually show you guys the compilation that Dane put together of the V1 camera over the whole past week here. So let's play that for you guys. What you can see here is on the left side, you can see what I've been calling this west pond. You can see it rising and falling over here. And on the right side, you see this west vent cone, which is now acting mostly as the gas outlet, right? And of course, when lava restarts, it'll burst out a bunch of lava from it as well. And not just this cone, but there's a whole lineation, a whole line of weakness that goes along more or less in this direction. It kind of lines up underneath this pond, and so you see gas coming out from there. And when lava surges out, it surges out both from the top and from the sides and beyond the field of view of this camera. In fact, let me play that one more time. Let me just zoom in here on this vent, this pond area, because you really can see this nice channel that's developed between the main overflow area and the pond itself. And I've been keeping an eye on this because you can see that finally here at the end, the lava level drops down enough where the pond is no longer draining back into the main lake area. Maybe I can find that frame and catch it. Pause it for you guys right in there. And we can see this lava level a little bit lower right there, and you can see hanging here this channel. That's the outlet point. And we haven't seen it look like it's this exact profile before. It seems like it maybe is closing in from the edges, but it's also carving its way down. And so interesting to keep an eye on that connection. And depending on the camera angle, you might see this thing actually connected to the main vent, or it might be like there's a little gap there, depending on how deep within this canyon the lava actually is. So I thought that was pretty cool. Most of the time, it's actually flowing that way because it is such a deep cut through this connection point right here. That's a V1 for the last week, and we'll move on to show you guys the S1 camera for the past 2 weeks now. And this gives you a little bit more of a visual history of what's happening with Kilauea volcano over the last 2 weeks, this current pattern here. So different point of view. So we were previously looking in that direction. So now our west vent cone is over here, and our west pond is right over there, and it's spilling through that canyon into this larger basin, which is where most of the lava sits when the lava lake is full. Right, that area has also shrunk from a larger extent over time to this smaller footprint now. I call it a footprint. It almost looks like it's got toes right there. All right, so let's play this last 2 weeks and show you guys this pattern. It goes day and night, and so you see the lava levels filling that lava lake area. You can look at the margin here, and you can see the wall has become darker. And of course, the lava drains away. You still see some circulation within that west vent pit. Restarts with a big burst. Lava flows all the way along the crater wall to the southeast this way. You can see a lot of fluctuations up and down without pausing within the last week. We'll show you the plot of that here shortly. Almost like it's breathing in a way, right? And then one pause that occurred and a burst back through that came through recently that not only filled this main lake area, but also overflowed off in this direction. So we'll see some nice views of viewer submissions from John Tarson over here. And it's also put out a big flow in this back direction over here and filled a lot of this back area, which is now growing, and it's getting to be a wider footprint of the volcano's crusted lava lake over here. We'll look at that in a little more detail as well coming up. Different point of view. This is the KW camera. This is looking from above. So here's our west pond. The west vents over here is just this little single point of orange, the glowing hole on the top of the cone. Try to zoom in a little bit as we go here, but before I get it going, from this angle you can see that spillover zone is more down over here. But there's also in the background what we've been looking at over the past few weeks here, that eastern part of the lava lake that's been putting out flows and spatter and kept this activity going here in this back wall as well. So we'll play through it here. Zoom it in for you guys a little bit. So there's that activity in the back continuing. You see this is that whole down drop block area. It's still active. And so that main core of the crust of the lava lake is back in here. Something in there now. So it's leaking up around the perimeter everywhere, but it's been doing so a lot more in this north section and this east section where you see this lighter colored lava extend like that. Full horseshoe shape like that. Here's this most recent flow that comes and covers all the way down to the side. You see it does it a couple times. It seems to be partly because this middle area seems to bulge upwards, and then that makes everywhere else downhill from there. So when it spills over out of this west pond towards the crater wall to the north and the west, it can then fill this big trench area right through here, right? So this area is being filled from overflow from above, but also we've seen it before leaking from below the crust and coming up that way as well. Maybe easier to see it in thermal view. So here's a thermal camera time lapse for the last week. And there is most of that down-drop block area. That spatter cone area is back in here. And here's where we've had some previous ooze-ups. But this is the pond, and the pond itself is what's going to be spilling over in that direction when the output increases again, right? So here we are, we see the pause, and following a pause is when it comes out with vigor, renewed vigor, and comes bursting out everywhere and floods that other area to the side. See how much pink is on the screen here. It's from this angle, which is obviously skewing this closer side of the crater quite a bit compared to the far side of the crater, but this close area over here seems to be quite a bit larger than the actual active lava lake surface right through here. So that's why it's becoming more and more noteworthy. It's, these are big flows and covering big areas. And it seems like the core of this complex is becoming more central and also going towards the center, right? Not because it's moving so much, but because you're building up this buffer zone on the outside between the pond and the west vent and the crater wall. There's a bigger margin now. Okay. So looking at what the last 24 hours from the USGS here, I like to reload this as we go along because as this is a live broadcast, sometimes things change while we talk. So there is that west pond. You can see that not as many overflows, but we do see an outbreak that seems to be coming from below. Perhaps it's building some kind of pond in here, which is overturning. It's hard to tell just from the thermal images right there. And you can see the extent of this all through here. And the animation for the last 24 hours that shows a little bit more staggered frame here, that progression. So that's what's been going on in Kilauea for the past week. I wanted to show this graph of the whole eruption back from September to now. So this is not quite 5 months, but it's going on it now. And you can see this laser rangefinder has been pointing at slightly different points in the lakes. There's a couple little jumps and variations here, but the overall pattern is it rose quickly at the start, is rising steadily since then, and we've seen really since the laser pointed to the filling and draining portion of the lake, more or less in here, we can see more obviously this fluctuation in the lava level. But the overall pattern, I'm showing at the scale, is the overall pattern is still a filling trend, right? As that's more obvious from here. So we'll look in more detail here. This is the 1 week plot at the top here of lava depth, and so this down here was our single pause during this last week. We had the lava level drop down and rise up, and drop down and rise up once, twice, 3 times, 4 times, 5 times, 6 times before that pause, and then once immediately afterwards. These are not full pauses, right? It's hard to tell from this plot exactly, but it's more distinctive because when it's reaching its bottom, it's flattening out like that. That's when it's really giving it a chance to fully drain, right? Whereas here we're not all the way draining before we're refilling it, before we're even done draining. This is not quite a pause. And this is more so a pause, and with the caveat that the lava is quite always active within that pond area, even overturning. So these are not true pauses in the sense where there's no lava visible on the surface anywhere, but they are pauses in the sense where most of the amount of lava coming out has stopped. Surface, at least, yeah. So on top is the lava depth. On the bottom is our ground tilt, and you can see a very clear correlation between these two signals here, right? You can see that. Even as lava level is draining, the pressure will start rebuilding. And when the pressure finally is able to burst to the surface, that's when you start seeing the lava come out and lava level refill. And correspondingly, you see the pressure drop back down again. So there's a little bit of an interplay between the two. They're not exactly. There's a slight causal relationship here. Offset in time here. But what you can see is that, unlike the previous week where we had a couple of these events that did not reflect on the depth, everything is once again tied 1-to-1, as you can see here. So looking at the last month, you can more clearly see that bigger long-term pattern. And more so in the last week, it's more obvious because we haven't had as many as these big draining events, like 1, 2, 3 here within that previous week, and just 1 in the last week, and many more of these smaller ones, smaller variations. And so it's not clear why this is actually happening. We put out all kinds of ideas, but suffice it to say that there is, some evolution of the the delivery system of lava to the surface here, right? Whether it's the actual the way the nozzle is configured, or there's a pathway, or it's the reservoir itself, or it's the entry to the reservoir. There's all kinds of factors in there that we could consider, and probably not worth diving into that level of detail. Just suffice it to say that something is evolving there, and it's leading to a slightly different pattern. Right? There's that increase that you see visible in the lava depth, whereas in a ground tilt for the last month, pretty steady, not really a net rise or fall. You see all this variation in between, but this seems to be something driven from the reservoir pressure of the magma below, rather than any fluctuations within that reservoir, rather than any long-term trend up or down. So correspondingly, when the lava levels are not coming out as high, when lava output is not as high, we have lower gas output as well. And then when it surges back forth, we see more gas emissions. So this is a continuous monitor at Sand Hill at Kilauea Summit National Park. This is in an off-limits area, so likely you'd see much lower values than this, up to 5 to 6 ppm you see over here that's registering on this scale for SO2. Even so, gas remains the most significant impact on people. There is still VOG, and there's more VOG when there's less pauses, as we had this last week. This is just a single point where the wind blows the gas over the station, whereas a more integrated measurement is displayed in this 1 month plot here. You see measurements that range up like 4,500 tons per day within the last 2 weeks here, but also as low as a few hundred during those pause events there. So when we look at the VOG forecast as the main impact here, we've been looking quite a bit at this weather.hawaii.edu VMAP project forecast, and it's great. It combines the geographic source of the VOG with the weather patterns here. So it's giving us a indication of where that VOG might be blowing, and concentrating, collecting over the next 2 days here. And so you can see the pattern is largely around the summit, and you can see when you have slack winds that can go north towards Hilo. But a lot of times it's going on an uphill of Pahala side towards Ocean View, and uphill of Naʻalihu area right through there. But I wanted to point out this plot today. There's a parameter list here on the left, and so I wanted to zoom into this so you guys can see. And in their inputs here, they've put in SO2 emission rate of 333 tons per day. So the point here is that they're doing the best job they can, but it's very tricky to keep track of the changing SO2 emission rates and know exactly the pattern. So we'll take this as an approximation of what might go, and rely less so on whether it's actually going to be a hazardous level or not. And more so an experience that these levels of VOG have not reached the hazardous levels in recent history. And that's what to expect. Is VOG dispersing, maybe not reaching hazardous levels. Looking at the National Park website for gas, and this is the HawaiiSO2Network.com webpage. You can see everything's in the green. Weak winds, only 5 miles an hour at the summit. That's why it's showing a circle for kind of where the VOG might collect. When a wind's stronger, it might show like a triangle or something like that. That shows it's blowing from one direction. It's dispersing the other way. But it's more slack today, and even still, everything's in the green. You're considering visiting the park and you want more information, you can even go by site. You can look at all the different sites for SO2 in particular. So we can just scroll quickly down here. Everything's in the green as usual, except for SO2 at Kahuku, which this middle of the day, more or less, had some SO2 blow across there. This is Kahuku uphill of Ocean View area. So as we just said, everything else showing green all the way down. And while we're talking about the park, I'd like to keep giving you guys a lava viewing update, an outlook, right? So what's it been like over the last week and what to expect ahead, right? And overall, we still have occasional pauses, so that's what to watch out for. But the main viewing area, you see most of the west van is still from Kanakako'i down over here in this south part of the caldera. But there have been views with that activity on the eastern part of the crater floor visible from Uekahuna area up in here on the north side of the park as well. So we'll show you guys some samples of that submitted by our viewers. But of course, just to mention, as you guys are considering visiting the park, to check the National Park webpage for all their changing alerts and closures, and they have a whole page on eruption viewing. You guys can consult more detail. Just trying to give you guys what's changing from week to week here. So I like to use this S1 camera over the last 24 hours as an approximation of what people might see from that southern overlook. So you can see at times this entire lava lake full of lava and circulating, and when it's doing so, there's all kinds of small features you can see, bubbling and convection, and we'll see a submission of whirlwinds over the lava today, right? Little lavanedos, as Dane and others like John like to call them. So that kind of stuff is on there as well. But as far as the vent itself, you can see sometimes a lot of gas coming out. During these reactivations, you can see spatter bursting. Sometimes you can see actual fountaining. We'll show you guys a video John submitted of some dome fountaining coming from here in just a minute. And of course, the other thing to mention is as lava is spilling over around its backside, that's also visible from that back wall, from that south side of Kīlauea. So you can see most of this area. You can't see as much over here. Like this is more the blind spot down here below at the bottom of the screen. But you can see much of the other stuff all through. You also can't really see as much the eastern side, although when lava has been really pumping, some of that spatter has been rising above the blockages and becoming visible there as well. So the overall pattern, overall story today is lava lake continues to fill. And as it fills and gets higher, it's becoming more and more visible from more and more places. And it's, worth, if you're a local, worth just doing the rounds over and over around the park because there's more stuff visible every week from new places. So that's really cool as a local here to live through that. Changing views is not something you get in your landscape all the time, right? With so much drama like this. All right, so show you guys this video submitted by Mr. Tarson. You can see he's obviously using a high-powered telescope here. Get this a little bit more, filling the screen for you guys. All right, so John Tarson with Epic Lava Tours. Mahalo, you guys, for your continued submissions. And if you guys are other park visitors, you can also submit things to us on hawaiitracker.com, Hawaii Tracker Facebook group, and also can message us as well if you want to make sure that we see something we can share with everyone else that's unusual or prompts a question here. But are you seeing this, Dane? Do you see these large plates of lava getting whipped up by the wind?
Yeah, that's really interesting there. Really strong wind. that I remember we were talking in the 2018 eruption about how those vortexes could be so strong that it might have started one of the fires that took down the PG cam by the Puna Geothermal Venture. And to do that, it would have had to throw a piece of molten rock, what was it, like 40 yards or more? Something like that, just to get it onto the dry grass. But that was kind of the best explanation, is some kind of wind picked up something and threw it from the channel. But seeing video like that, you can believe it, right? Yeah,
quite possible. Yeah. Possibly not even molten, but solid and very hot enough to ignite all that bone dry grass that had been killed off by all the gas and dried out by all the lava. Just the wind of it. Right. Absolutely, yeah, no question, that's viable. Absolutely. So yeah, interesting to see that, right? And I also like this because it really illustrates how thin the crust of that lava lake actually is, right? When you see the crust getting ripped up and flung in the air like that. So mahalo for that. And we'll show one more submission from John here, and this is zoomed into the west vent itself, and you can see this is during that reactivation early in the morning. It's still dark before sunrise. And you can see there is out of the side of it a nice dome fountain, and you can see this nice big spatter burst coming out of the top of the cone here on the right, and all these channels. And John relays that this is some of the most lava he's seen coming out of the volcano, at least in recent time here, right? It's hard to compare this to anything that happened in Lower East Rift Zone, of course, right? It's a whole different ball game. No people around, no houses around. It's just like in that lava stadium in a hole where it can't hurt anybody. That's still the case. And within that context, and within that crater, this is a really impressive thing to see. So, and check those guys out, and check out the park for different views. And we'll show you guys one more view. This is a view taken from the north side now, from Uekahuna, of just a plain photograph. You can see that Kīlauea viewing area, flashlights, people over here. They're looking the opposite direction. Can't see the main vent behind the cliff over here. You see it glowing, but underneath this cloud of fume. But you can see those overflows that make it to the eastern part of the crater floor. You can see a little bit over here and a little bit over here as well behind this vegetation there. So this area, the reason I point this out is this is a place that you can, it's only 1/8 of a mile. It's close to the Jagger Museum parking lot, and it's something that doesn't require as long of a walk to the Kīlauea overlook. So this may be more accessible for some people, although in all honesty, that Kanakakoi hike is so easy compared to the lava hikes we used to do down in Kalapana or on a rift zone, Napao or that kind of thing. So viewing is still good. It's good from both sides, and we're not sure how long activity will last from this north side. It hasn't been that case the entire eruption, but it is back visible from the north side once again. Okay, that's going to bring us to our time lapse of the week as we discuss what's going on that north side over here. So we're going to turn to this last week of action from the B1 camera, and I'm going to loop this a few times and just show you guys here. There's the main lava lake way on the far side of the crater from here, and the west vent, that pond, and that overflow zone, that trench is all back in here, right? So that's what we're looking at earlier in our broadcast. We're not focused on this far back side of the crater, and we've been looking at the little hornitos here and the overflow block down over here, right? So I'll let this run through one more time, just so you can see the extent of some of these other flows that come around this way or come out this way as well before I zoom in to the action right in there. And note, the camera did freeze a couple of days ago, so we do have this little hiccup in the end here, because that is unfortunately the nature of these remote web cameras, that they do sometimes break down. And so unfortunately that one being more remote, I'm not sure when it'll come back on. So we'll appreciate this as its perhaps final contribution for a little while here. So wanted to zoom into this here, and right in here is where that little hornito is. So see it growing up right there. There it is. And by the end of this time lapse, it's no longer in existence. It's buried, destroyed, flooded out by the lava. But what I really wanted you guys to see is, if you hopefully this is coming through, you can see this whole area right through here is bulging, right? You can see it bulge up before the cone pops open. Then as the cone emits lava, you see it sag back down and it bulges up over here instead. So it's almost undulating the crest back and forth there. So let's see if you guys can catch that. There's a bulge up, there's a spattering, it's bulging back down, bulging back up, back down. It's almost like a waterbed rippling, the way I see it, right? I see it kind of, it's almost like big gas bubbles coming and pushing out and sending all that lava out, and then it moves over here, and that part rises up, and this part sags, and I find this fascinating here, and something that perhaps we'll get more insight from USGS on the dynamics there, but this gives you a little insight as well to how that whole area that looks like solid lava is just that crust, and the whole thing can bend and deform under that mass of lava all beneath it. We talk about all the time, but can't really see, and this is perhaps one of the pieces of evidence that we have that gives us insight into how fluid and how much lava and how bendy that whole surface actually is. All right. So we'll move on from that time lapse and show you guys some of the media released by the USGS this week. There's not a huge amount, but there is a combination of photos and video. So here's a photo from not quite a week ago, showing that overall landscape, right? Similar to our KW camera, and slightly better resolution there, but West Vent Cone, West Vent Pond, Western Pond. Here's the previous old West Vent area, and so this gives you an idea of that area to the crater wall right in there. I may come back to that later, but leave it for now. There are areas where you see spattering, as you can see the pattern of flow from the main vent. Maybe if I scroll it down more, it'll be more obvious, right? There's that West Pond spillway, main lake area here. The crust is dispersing, and we discussed how it actually recirculates through these caves that appear to be lava tubes that put the lava back underneath the crust that are somewhere over here and somewhere over here as well. Often what happens when you have that occurring is you have the gas bubbles bursting out, and that helps drive the whole flow of things as well. So you see some of the bursts of gas that are at that margin, and sometimes you see them in the middle of the crust and get carried across to the margin as well. So that's still going on. There's one of those marginal bursts right here. Abundant spattering in a perched active margin lava lake. And looking more closely at that west vent itself. They are still reporting hearing gas jetting noises and seeing spatter coming out occasionally, and that's a surprise when you guys saw those videos taken from the public overlook. We will add that to this USGS video, and I will warn you that I've sped this up and I'm playing it at twice the speed here because I don't want to take a full 5 minutes of our time. But it's showing you guys a big picture, lots of the gas coming out of that west vent here, the spillway area spilling into the main lake. And you can see, depending on the angle, you can see more of a curve to this or more of that straight channel, right? See pieces of that skin getting pulled apart. And when you're looking at the thermal camera, quite often this gives you an indication of the vigor of the eruption, right? The more crust you see forming over here, the slower it's coming out. And once in a while, it'll overturn and resurface its entire top. Here you see that convection lava flowing that direction, right? There's that spattering in the middle of that crest that's being carried along there. And you see it steady at the margin further up there and right as well. A slightly different view. There's that at the edge spattering source right through. Interesting patterns here as well. You see all the coils of rope. You see the zigzags that help all that fluid, semi-solid crust move and circulate. It deforms, carried across the surface. All right, I think this is. Pause that there. So one other picture to show you guys. This is, I believe, also from the north, showing a rainbow coming in over that area. And if I zoom it in, you can see a little bit lower level of that lake. You can see quite a bit of this wall up here and flowing through the canyon, right? So besides the fact that this is likely putting a lot of lava and maybe carving its way, keeping that pathway open through carving it, you can also imagine the overflows are adding more layers to this whole surrounding area. So the whole area is building up around it, and then it might look more sunken in from that effect as well. And then when I just go over here to the side, there is that reddish colored, which is the old cinder, now red cinder, baked cinder of the previous eruption's west vent. And you see a series of cracks next to it over here with some fume coming out and a wide margin all the way to the crater wall over here. This crater wall was an area that had quite a bit of steepness before, and it seems like we've been riding up against that steep scarp, and we're now coming up to where it's still steep, but it's not as steep as it was before. So we may see in the coming weeks here further flooding of this area over here. That's in the northwest corner quadrant of the lava lake surface there. That back up. Show you guys a slightly different perspective. Zoom there. Right through there here. So to illustrate this, we'll look at this as our curiosity this week, is that changing shape of that pad of lava there. Our most recent map from last week of the flow areas. It shows this big, we'll call it an ear over here in the northeast. That is that most recent downdrop block that got covered. But we've also been pointing out that there's low ground on this northwest side over here, and so it may be that we're actually developing a second ear here, right? It might look more something more like a cat or a bear or whatever creature you choose to fancy there. But there's that old west vent, new west vent, and here's that area we're looking at that's growing. And there are contour lines on here, but it's a little bit hard to see them since they're gray on grayscale as well. So we'll look at the older map once again, but on the way I want to just stop in at the USGS update here and just remind you guys this is a source of a lot of information. If you'd like to get daily variations here, they are doing a great job at writing different stuff every day depending on what actually happened the previous 4 hours. It's more detailed than some years past. So that's good, but in particular for our discussion now, I'm going to pull out this number that the surface of the active lava lake is at 835 meters above sea level. 835 is our number. That's 2740 feet above sea level. Depth of approximately 94 meters or 308 feet since it came out on September 29th. Now that's across that much wider, flared out crater diameter. So it's actually quite a bit of lava that's come out. It's still quite a healthy eruption despite all the pauses that are coming. 835 is our number, and I do that because I want to come to this plot that's back from the last eruption, April 2021, but it has on here in purple 900 meters and green 800 meters, and the contours drawn in meters as well. So I'm going to zoom into this. I'm way further here, and you can kind of look at this green outline at 800. As you saw, that's where we got our first cat ear right over there. This big flat area. If I make it obvious to you guys, these black lines are the contours. The green one is one also, but you can see there's a big gap between that contour and that contour, right? That means flat land all through here. That's flat land, like there's a gap there, that's flat land, and when you see them close together lined up, that's steep land, like that, and that's extra steep land when they're really close together like that. So that's that end is obvious, and if we're at 835 and these are 20-meter contours, the line now actually is somewhere here. It goes like that, up and over, and it's probably up in like this right now. Grown to be broader there. If we follow this around, the 835 line goes somewhere through here, right? You can see that this big cliff has been largely overcome, and now there are rising contours, but they're at a much lower gradient. They're farther apart than over here, right? So the ground has become flatter, so it's kind of got over this little lip here of where it was steep, and it's now going to be able to right onto this downdrop block area where it's lower here as well. But to follow this continuing around past this little lip, you can see that right through here, it would come out and it flares out to there. So if I follow that contour around, right, this little notch right here, that is our developing second cat ear right through there. So this is the area that we're seeing lava coming and filling and expanding that zone, right? So this map is from the last eruption. This red was a lava lake, and in this plot, this yellow was the old west vent. So this has become the reddish rock that we saw with reddish cinder right there on this previous map. There, and there's that gap right there, right? So this map is almost 2 weeks old now, but what we're pointing out is that this is where we're coming up, fill this area right through here. A little bit of a notch, and it might right up that area. Curiosity this week. So here is a picture that I pulled from November 8th, 2021. So this eruption, right? And there's our west vent. There's a marginal lava lake. I got it zoomed in a little bit here, but for comparison, I will flip it forward. What it looks like today. So you see, harder to see as well, but let me point this out. There's a little triangle kind of light ground right here. Same, right? You can see the gap we have. Now advance it. There's that triangle. You can see very little distance with the lava from the tip of that triangle right there. Back one more time. Show you guys how much over here of this land has been covered by that rising lake there. Pretty stunning. I'll try to bring you guys some visualization of this as it progresses over the next few weeks here. You really see that little tip, right? That's the little beginning of that cat ear, as I've been calling it today. And from last evening, showing you guys the extent of that new lava flow. So that is the area where it's flowing. All right, so we'll take a break right here. We're going to still cover earthquakes in Maunaloa, but we can say our thank yous, Dane.
Yeah. Do want to appreciate everybody that did show up today. Viewers like you really do drive this stream in terms of getting it seen by more people. We don't have advertising budget and all that kind of stuff, so we rely on the viewers to share, like, subscribe. That helps with the YouTube algorithm and all that jazz, but it really does help. Do want to thank Judy, who donated $25 and said, great reporting as usual, guys. I appreciate the support. If you do want to support us, we do take super chats. We also take donations on hawaiitracker.com. That is where we post all of our content that we make in chronological order. So you can go there and get the just the feed of what's happening most recently. We also take donations there on hawaiitracker.com/support if you are so inclined. We do want to thank our supporting business, Kilauea's Bar and Grill in Pahoa, as well as their new location in Orchidland. They have two unique menus. indoor outdoor dining. The Orchid Land one is partially an outdoor dining experience. It's really good. They have takeout, all that kind of stuff. So definitely check out Kilauea's, and we appreciate them for being a longtime supporter now at this point of this live stream and the content they were able to produce about providing information on the volcanoes. So we have a couple questions here if you're ready for those.
Sure.
All right. So Two Pineapples points out that, or asks about the high tide, the tides having effect on the eruptions resuming. Points out the past months, several have resumed at 1 to 2 post high tide.
Yeah, it's a good question. I have not looked into that, but we'll have to look into that. So yeah, thanks for pointing that out. We'll look into that. I mean, the volcano, I've said before. Dane, I think I lost you in camera. Your camera view. Maybe you'll come back. I've mentioned before that when eruption is in that balance point of equilibrium, then you can have those very small changes actually affecting and tipping eruption to start or stop, or one way or the other, right? We discussed we have an open lava lake right at the threshold, and maybe the tide is that last straw that breaks the camel's back, but it isn't that strong a force compared to the actual force of, let's say, a extra magma coming up, right? So that said, I think that this is a very, very optimum time that the tides could have influence like that. So yeah, we'll have to look into that and maybe show some plots that examine that relation coming up here.
Right. Not exactly sure what's happening. We'll have to figure this one out later, but not able to resolve it right now. All right, so getting into the next question. Yeah, we have talked about that. Oh, okay.
Gotcha.
I don't know what's going on.
I clicked the right thing apparently.
Yeah. I think we covered this last week, but it'd be good to rehash. MI says, or asks about the magma coming up now. Is it relatively low or large amount of dissolved gas? Is it fresh magma from death, or is it stuff that's been around that's coming up recently?
The reports that we've had from the USGS as far as the CO2 SO2 ratio are suggesting that the magma has been stored in a cement reservoir system for some time. But that CO2 SO2 ratio only really is a fairly deep threshold when we talk about deep and shallow. So that's the first question when we talk about what depths are we talking about, really is the question, right? So it probably comes from within a main magma reservoir area that's, we'll call it 1 to 3 miles down-ish, right? Maybe down up to 5 kilometers, or so with that lower South Caldera chamber. But even then, it still has all the SO2 dissolved in it. And when it comes up to within that last half mile of the surface, that's when that starts to come out. So yes, the gas is dissolved in the lava and the magma, and as it comes out, then it does bubble up and out. So from that perspective, it does have a fairly large amount of dissolved gas, right? And it is fresh magma in a traditional sense of what's normal for Kilauea, right? As far as that CO2 SO2 ratio that I started off talking about, that might be something that's more like outside of what we've seen behavior in a historical time here, right? It might go back to possibly the era of explosions that we saw tephra and that kind of thing that we hear the legends about. So yeah, I mean, in short, yes, it's like all the other eruptions in Hawaii. It does have a good amount of dissolved gas in it, yes.
All right.
And yeah, coming from deep in a volcano, what we'd call deep from the system, enough that it still has all that gas dissolved in it, and not something that erupted, let's say, and formed a lava lake at the surface, and then later just got mushed and pushed around. So it's not that kind of thing.
All right. Joseph asks about the lava lake level that it is now compared to the pre-2018 collapse. Is it getting close? So
in elevation, it's probably come over halfway up but the thing is that the crater flares out much the hole was very steep at the bottom, and then it got a little less, and then it gets less, and then it gets less. So the higher up you get to the top, it's going to be harder to reach that same level, right? Because we got to fill a broader area all the way across the entire collapse zone. So
Yeah, and those down drop blocks are pretty big. A lot of size there to a volume to fill up.
Yeah, and that's a good point tying that in, because that's really the consequence of talking about all those down drop blocks and the lava being able to spill into that area today, is that it actually can spread out more, and then that slows the overall rise level, even if the volume level coming out is the same.
Right. All right. Last question for this round. Terry asks about Kilauea Iki and the olivine crystals that we find in the Kilauea lava. Do you think that there's a bunch of olivine at the bottom of that lake, or that's now solidified?
Probably. I mean, the olivine is solidified within the liquid magma, and then it kind of settles out, right? And then the rest of the liquid stays liquid, and so you have kind of a mush layer, and then you have a more liquid layer. But yeah, I mean that's something that's thought to occur in all magma reservoir systems, right? So that probably happens within a lake. It happens within the upper Halemaʻumaʻu chamber. It probably happens within a lower South Caldera chamber. It happens everywhere that it has a chance to cool. Let's call it, yeah.
Right. All right. Well, that will do it for this segment. We will be doing one more segment of questions and answers. So if you got anything that you'd like to ask Phil, go ahead and throw it in the chat, and we'll try and get that to happen.
Yeah, and we will be opening it up because we're going to be talking about the last decade of eruptions, right? So that's going to include lava flows in Kalapana and Pu'o'o and 2018 as well. That's going to be our last video from Matt Patrick to remind you guys. So at that point, you guys may have questions that span a broader range of topics than we've covered so far. Okay, so that said, we'll get back to the update here and look at some geophysics, look at the GPS signals here across the summit at the top. And this was the eruption in September, and you can see that there's not a whole lot of change, although you can pretty easily now see this very slow extensional trend. So despite the lava getting out the top of the volcano, it's still building pressure below it to start expanding and swell it still, right? So we have a net gain of magma into the reservoir still, it appears, at a fairly slow rate. And I say it's fairly slow rate because this plot goes back a year. And a year ago, we were having an eruption as well from the previous west vent, and it was also extending as it was doing so. And you can see it was extending at a faster rate at that point. This is during eruption. That eruption ended around in here, and you can see it kind of picked up a little bit there briefly. And but really, a different background level of extension before. It's slower now, but it is an extensional trend very slightly there. And on a rift zone by Pu'o'o, we see the opposite contractional trend. It's still been contracting ever since the eruption there, and some smaller deviations, but overall the pattern still holds. Looking at earthquakes, we're focused on Kilauea still here. We're going to turn to Maunaloa shortly, but we'll use earthquakes at bridge across. On Kilauea, levels have been fairly quiet here. This is that basal underneath the summit swarm that we talked about a couple of weeks ago for the last year. So here it is in the last month plot, and you can see really in the last week it's been nothing abnormal there. Seen on a map, view still occurring under the summit region, but not at any alarming rates. I imagine you probably are still feeding magma in. It's still swelling and cracking and extending and all that, right? And possibly that's a cause of the evolution of the magma system too, to change that deflation pattern a little bit, but we really don't know. Pahala still continues with those deeper blue earthquakes there, and we still have a couple of blue deep earthquakes in that feeder zone to the summit of Kilauea here as well. Otherwise, south flank. These are all normal areas for activity, and there's nothing unusual to be alarmed about there, right? Cross section, you still see the deep Pahala ones. You still see quite a bit of shallow Pahala earthquakes, as well as the south flank. Here's Kilauea summit, deep ones, shallow ones. All right. Down here is a timeline. This is depth, longitude, depth, time. So the deep earthquakes are, you always have a little bit of clustering, a little bit of gaps, but it looks like it's fairly steady in both shallow and deeper areas here. For the last month, they actually include that whole deeper swarm there, Hala swarms as well. You can see more of that picture of that plumbing system as we discussed last week. Up, and then a stress above the magma areas right there, but no connection under Pahala still. And then really, in comparison over the last month, here is that deep earthquake swarm, and really nothing popping back up in that area ever since then. Little more in the shallow areas, a little bit less, and you can see maybe we're back to normal shallow zone activity. Okay, so that's the earthquakes on Kīlauea. We'll look at the earthquake map here. There is that Pahala zone. There's a Kilauea zone, and then here's our next topic of discussion. And see that there is one kind of off the north flank, one Mauna Kea, and a couple of west flank earthquakes, a few southeast flank earthquakes, but most of what's happening in Maunaloa now is northwest of the summit, under the main caldera, and the southwest and that upper southwest rift zone area. These are the same areas that we pointed out last week as having lots of seismicity. Right, we showed you the plot of the whole last year to show you guys that area, and lo and behold, this week the week-long earthquake map is showing similar patterns. There's that cluster to the northwest, there's that sparse signal underneath the main caldera, and there's that upper southwest rift zone. You can see here in cross-section, a little bit deeper to the northwest, a little bit shallower above the magma chamber. Magma chamber is probably something like that. Reservoir, the whole, I call it a chamber, right? Just out of habit still, but really it's not necessarily one oval bulb or whatever. It's just a reservoir network of all the different blades and magma bodies that exist with that edifice there. And looking at the last week here, you can see that it was Friday and Saturday that we had but maybe close to 50 and then close to 60 events on back-to-back days in that area. Come back down since then, so a little adjustment. This is normal, as we discussed last week, the whole cycle of the summit flaring up and extending, and then the size moving, and so you just see more of that pattern, and it seems like it's a little more active than before. Here's our whole last year of Maunaloa, so here's that earthquake spike for the last weekend, and you can see it's higher than anything we've seen really in almost a year, right? So it was not anything close to what we saw in that big adjustment a year ago, but it's coming out of the background more so now than it was before, right? And looking at the cross-caldera GPS distance across the summit of Maunaloa, here is about a year ago, that larger adjustment, right? You can see quite a bit of extension and contraction and then back, right? We're seeing something similar, but at a much smaller scale here, right? It was extending, contracting, and maybe now appears to be extending again. So that seems to be the pattern. It seems to be out of neutral and trying to start shifting back up. And interestingly, we can see that the tilt, which is something that's really hard to decipher Maunaloa, so nothing definitive here, but interesting to note that at the same time we see this turnaround. Right, so this could be something else besides the change in magma pressure, because we're very sensitive to all the tidal forces here, right? So you could have some more seasonal changes coming through. So I'm not quite sure exactly there, but we do see very, very slight and essentially not a whole lot of major activity. Just the daily up and down signals is all you see here in this Maunaloa. It looks like a whole lot of action. Like maybe if you've never seen this tilt plot before, you might be thinking everything's going crazy up there, but this is just nothing and normal, and maybe the only thing you can tell is like it was slightly going down and that's slightly going. Maybe if you could exclude other sources, orbital forces, you could say something more about the volcano here. Okay. Snow is melting, but as we've been tracking the views of the summit of Maunaloa, showing them every week here, still a little bit of snow up there. And we will turn to a couple final things before we switch to our talk. This week's Volcano Watch. The Tonga eruption was recorded in Hawaii Infrasound Network, right? So, of course, it was recorded all over the world. It was heard in Alaska, but Hawaii also has the story of recording that here. So you can read through this Volcano Watch, which will be posted to hawaiitracker.com shortly if it hasn't been already. And you can see what they're discussing here, right? And part of the discussion is whether this energy is audible or not. And one quick point is when the waves are coming far apart and slow, then it's a low frequency change. But when they're really going back and forth a lot, then it's a high frequency. That's when you might be able to hear it, is during these little pulses here. This is not enough, and this signal to be audible, but this is how you get to that kind of dispersal of energy and analyzing how that goes across the globe. So they do refer to something that we considered showing a few weeks ago, but since I refer to it here, I will play it since it's a visual thing here. This is from Mauna Kea, noirlab.edu, and you can see here various views from some of the Mauna Kea, and you can see some high clouds coming across, but you see the pressure waves coming across right here. Coming across the view here, you see them fly across the sky in opposite direction as the clouds from different points of view. This is Mauna Kea summit, covered in snow. See them coming right to left here, those pressure waves, and opposite the clouds. Fourth are coming left. That was it. So I thought we would do a couple other extracurricular things here today. This is a tweet by Sam Nestor, who designed a short sample of the work of converting earthquake data to musical parameters. So this was taken during a residency at Hawaiian Volcanoes National Park. So I think we'll hear more about this in the future. But let me see if I can get this to play.
Might need to unmute the Twitter.
Did you not hear that? I thought I heard it coming through the audio here, but
Yeah,
if not, then
it
we'll
is
drop the link in chat.
It is working. Sorry.
You guys can check it out. Yeah. So yeah, that's a little sample of it. You can see it's mixed with some footage taken during a residency here, and look forward to hearing more about that. I've always enjoyed that kind of exploration of the volcano here. Hello, that's Sam Nestor. Yeah. 1S Nestor. Twitter, if you go and check that out in full. And we will now turn to the video by Matt Patrick of video throwbacks of the past decade on Kilauea. Right, so he's going to cover the whole last decade. Right, that's back from Kalapana days, Pu'o, and so on, as we discussed before. So what we will do is turn it over to Dr. Matt Patrick here, and we will be on a chat, and we'll discuss some of the stuff afterwards in about 20 minutes or so when this talk is over here. Ready, Dane? Anything else before we jump into it?
Nope, go ahead and fire it up.
All right, so here goes.
Hi, my name is Matt Patrick, and I'm a geologist at the Hawaiian Volcano Observatory as part of the U.S. Geological Survey. And today, in this presentation, I wanted to basically show some video highlights of the past decade or so of eruptions on Kīlauea. So, as geologists, we're out in the field regularly observing, trying to make sense of what's happening with the naked eye. But one of the best ways to document, what we're seeing, of course, is with high-quality video. So here's an example on the slide of our 4K camera documenting the opening phase of the current eruption in Halemaʻumaʻu that began in September. So this is just to give you a kind of a map overview. Here's the island of Hawaii, also known as the Big Island, and Kilauea volcano is in the southeast portion, kind of within this box here. So, and here it is zoomed in, and so the structure of the volcano is such that there's a summit caldera here, and then there are two rift zones, the southwest rift zone and the east rift zone that goes down along here. And what I'll be talking about today are eruptions in kind of three basic locations. I'll talk about an assortment of eruptions at the summit, in the summit caldera, and then on the Middle East rift zone, we had the eruption of Pu'o that began in 1983, went to 2018. And then recently, in 2018, we had the very destructive Lower East Rift Zone eruption here in Leilani Estates. But first I want to talk about, well, the eruption that started first, which was the Pu'u'o eruption right here. So what you see are this video that we took a few years, I think 6 years ago, of a typical pahoehoe lava flow. And this is the type of lava that really typified most of the eruption at Pu'u'o. And you can see it's kind of slow moving, it's very fluid, has this kind of ropey texture, very classic textbook pahoehoe lava. And in one of these segments, this is shown by a factor, sped up by a factor of 20. And so it kind of shows how the lava is kind of oozing out in these toes, but at the same time, the surface is inflating. And so these pahoehoe flows kind of move in fits and starts as lava kind of extrudes along the edges, and then inflates, and then kind of extrudes again. So because it's slow moving, it's relatively safe to approach and sample. And here's Tim collecting a liquid lava sample here. And the reason that we do this is actually very important for the science and to understand the eruption and the hazards. This is meant for studying the chemistry of the lava. And the chemistry of the lava can tell us about where that magma was kind of stored in the volcano, how long it sat there, whether it has a direct route from the summit, magma chamber. It can kind of tell us more about the magmatic plumbing system. So these samples are actually very valuable to understand the eruption and how it's progressing. Now, I showed you kind of the typical activity, which was these slow-moving pahoehoe flows. But what I'm showing here is actually one of the more kind of fascinating phases. This has only happened a handful of times in that eruption. And what happened, this is sometimes some people call it a fire hose. It's basically where the lava that was entering the ocean, it usually moves, kind of builds a delta and kind of moves through lava tubes in the delta. But what happened is that delta and the part of the sea cliff collapsed, and it kind of exposed the lava tube high up in the sea cliff. So the lava in the lava tube was just pouring out. And here's a zoomed in view of that. Really fascinating. And of course, what you see are these small explosions, because obviously that hot lava entering cold ocean water, it's flashing the steam and fragmenting the lava. Okay, so we talked about the Pu'u'o eruption here, and now I want to go to the summit caldera of Kilauea. And what we're going to talk about is the eruption that began in 2008, and it went for about 10 years, 2008 to 2018. The lava lake that was active in Halemaʻumaʻu crater. So this is Halemaʻumaʻu crater, and then here is the old HVO building, well, and that was Jagger Museum. So here's Halemaʻumaʻu crater. You can see it's kind of a shallow circular crater, and within that crater there is a smaller crater, which is called the Overlook crater, and that hosts the active lava lake. And you can see the lava lake is composed of these black crustal plates with incandescent kind of spreading zones between, and there's an area of spattering here in the corner. This black lava is when lava briefly kind of overflowed the rim here in 2015. And here's a view from the rim. Again, a nice view of Maunaloa in the background. Yeah, again, you can see kind of these large crustal plates and incandescent spreading zones. This is kind of at dusk or a little bit after dusk. Very slow-moving surface. The lava is upwelling in this area and kind of flowing generally towards the south here, but it's so slow it's hard to see in that video. Here's a zoomed-in view of the spattering, which is pretty fascinating. This was happening almost constantly in the lake. And this is maybe 10 yards high or so. And you can kind of see the undulating lava surface as those bubbles break. The lava in the lake was very gas-rich. You can see it kind of bubbling here, and here's kind of a slug of gas that kind of reached the surface and burst. So this is another close-up of the spatterings taken at night. And what's interesting about this is it's kind of counterintuitive in the sense that what you see is the lava surface that's flowing towards the fountaining, right? I think that's counterintuitive because I think most folks would think that, you know, the fountaining is where lava is coming up to the surface, and you'd think that the lava would flow away from the source. But we see the opposite. And it's the way to view it is not as kind of the area where lava is rising up to the surface, but the spattering instead is actually large gas bubbles, you know, several yard-size bubbles, spherical bubbles of gas that are bursting. And you get all those gas bubbles bursting at the surface, and they kind of create a void space and a depression that the surrounding lava just kind of plunges into. And this pattern of lava flowing into the spattering sources was observed even in the early 1900s when the lava lake was active in Halemaʻumaʻu then. Thomas Jagger, who founded HVO, called it the down-sucking effect. And then Frank Parrott, who's another early HVO geologist, called it the siphoning effect. So both of those terms kind of give you the sense of lava kind of being drawn towards the spattering. Okay, so this is from one of our webcams. It's sped up. Yeah, and what you saw there was actually a collapse of the rim into the lake. The lake, you can see, is very gas-rich, bubbly, triggered an explosion. Okay, so what I want to show here is it's a video of from a thermal camera that's stationed on the rim, showing the lava lake here within the crater. And then these two plots kind of track the activity as the video progresses. And it's showing two things. It's showing the elevation of the lake surface in meters above sea level. And then it's showing ground tilt here. So the ground tilt is basically just, well, what you expect. It's showing when the values are higher, it's showing inflation. When the values are lower, it's showing deflation. And let's see. Yeah, okay, so we're tracking this through time. And what we're seeing is a really remarkable correlation between the level of the lava in the lake and the ground tilt. And we know that the ground tilt is actually kind of a proxy, or it's an indicator of the pressure in that underlying magma chamber, right? So basically what we see is that the lava lake level is mimicking the pressure state in the underlying magma chamber that's, you know, a couple miles down below the surface. And so what this is showing is that the elevation of the lava lake, it's kind of like a giant pressure gauge, or like a giant barometer of that underlying magma chamber. And actually this was helpful in hazard forecasting because obviously when you have, you know, an inflated kind of pressurized state, then you're more susceptible to eruptions, say, on the rift zone. Okay, so next let's talk about the Lower East Rift Zone. This is a major, one of the most significant eruptions on Kilauea in the past 200 years, and by far the most destructive, unfortunately. It occurred low on the volcano's flanks here, covered a lot of residential areas, caused a lot of destruction, and I'll be showing some slides from there. Okay, so this is the opening day of the eruption, or the second day in the opening phases, and we're here on this road in Leilani Estates, and you can hear this kind of beeping, and that's actually the house.
That's my parents' place.
It's a smoke alarm. But what we see here are cracks on the road, new cracks on the road, and some.
Sorry, I stopped it there, Dan. I heard you say that's your parents' place, so I think it's an appropriate time. And I mentioned before there might be some trigger warnings in here. I think it's appropriate to let you say something right here.
Yeah, so some of this footage in 2018 eruption, that looks like the footage that was released, except this is like an extended version of that. The USGS was trying to be conscious of like showing homes and stuff like that, you know, getting taken in 2018. So I think that little spin move that showed the home there, that wasn't released, but this is part of that longer video, or that shorter video, sorry. But yeah, this is, you know, if you live Leilani, this is going to probably be a good amount of footage of stuff that we may not have seen before, that, you know, just like that, I just watching real quick and it cut real quick and it's like, oh, that I know that place, right? So what ended up happening there is the fissure came up right under it and just destroyed it immediately. right up under the concrete on that one. So yeah, sorry if you see your place in a similar situation as this one, but you know, it's you're not going to be alone in that. I can say that at this point. We just got into it.
Yeah. I think I found immediately like hearing the fire alarm already triggering a little bit. Yeah, because you hear that from the beeping of emergency vehicles, like all kinds of noises of like warning noises like all the time, right? SO2 meters beeping, all kinds of things like you'd hear constantly. So yeah, we'll talk about this some more maybe after the video plays. Maybe we'll let Matt continue here with that little addendum inserted. Mahalo, Matt.
I'll be showing some slides from there. Okay, so this is the opening day of the eruption, or the second day in the opening phases, and we're here on this road in Leilani Estates, and you can hear this kind of beeping, and that's actually the house there. I think it's a smoke alarm. But what we see here are cracks on the road, new cracks on the road, and some fuming from these cracks. And you saw in that where the house was, there was a lot of fume coming up through the house. And we had been to this spot hours earlier, and it wasn't like this. So it looked like something was developing. So here we're standing on the road, and here's actually people evacuating up here. We have these cracks, and still fuming from the ground and the cracks. You see actually a little bit of fuming here. It's almost like if the ground is kind of breathing. I'll just let this play through. It's a little bit long, but the video doesn't convey it. But as we were standing there, we could also feel this kind of rumbling under the ground. So that was kind of ominous. The rumbling was kind of like a large truck passing by in the distance. And as we stood here over these minutes, it seemed like that rumbling was kind of maybe even getting closer or becoming more frequent. So you can see, this kind of steaming, fuming coming from these cracks. You hear that cracking in the forest? And kind of as we're watching this, the fuming does start to get kind of more vigorous here. Yeah, and on our left you can see the fuming is kind of getting worse. I'm just kind of letting it play through so you can kind of get a sense of kind of in real time what we were watching as this was developing. Okay, then, within moments of when that video ended, things got really bad really quick, and the fume just became super thick and enveloped us. We had to obviously put on our gas masks. Here you can hear police cars and fire trucks in the distance, and you can see the fume coming out of that crack is much thicker, and we've had to step back. There's some extra beeping, and that's our SO2 badge. That's alarming because the sulfur dioxide levels are very high, and that's obviously an indicator that magma is very close to the surface. So in that moment, the lava was reaching the surface, the fume cleared, baked off, and there was a chemical power lines on fire. You can see smattering large
All right, I paused it again there just to apologize. That's the way the video came. Unfortunately, that eruption sequence drowns out Matt's voice there, but you can see he's talking about the power lines being on fire. The lava coming up through that first fissure had big bubbles of gas. It would make big bursts and throw things high in the air, and it would land, and you can see the spatter on the road there, like all that new rock on the actual asphalt there. But the flows didn't go very, very far from those original cracks. That was that first phase, that older lava that was stored in the ground. So without knowing exactly what Matt said there, I thought I'd just add a little context and just point out that's what's going on here. And that's came with the original video, so we'll get back to it.
It's not very often that you see the opening sequence of a fissure, but we were lucky to be there, well, lucky I guess, to kind of document it as it happened. So that was the beginning stage, day or so of the eruption, and as the days went on, the next couple weeks went on, many other fissures opened and stopped and switched around. And eventually, within a few weeks, the activity focused on kind of the main vent, which was fissure 8 here. And you can see it has large fountaining, it's built a cone, and it's feeding lava into a large channelized flow here. We're standing on the rim here watching it, but the fountaining there was at times up to 80 yards high, but maybe more typically 30 to 50 yards. And this channel is really enormous, just because of the volume of lava that's coming out of that vent. Yeah, so, the eruption by the third week or so really progressed into large, fast-moving flows, very destructive. And here's one of the flows moving towards the coast, and you can just get a sense of all of the property that's being destroyed by this flow, covering farmland, destroying homes, unfortunately. So it was unfortunately very destructive. And that fissure 8 flow, the one that I showed where we were at the channel edge, within a week it migrated to the coast and it hit the Kapoho area. And Kapoho had a number of subdivisions, vacation land here, Kapoho farm lots, Kapoho beach lots here, and all of these subdivisions were totally covered by the flow. Eventually, the lava actually filled in this bay as well. So most of this area that you see in this frame is totally covered by lava now. So there were hundreds of homes destroyed in the span of just a few days, unfortunately. And obviously, as you can imagine, it was really tough, to see this level of destruction in the community. So this is a video of Katie collecting a lava sample, and kind of as I talked about for the Pu'o eruption, collecting lava samples, liquid lava samples, is very important to understand the source of that magma, and this was particularly important for the Lower East Rift Zone eruption in 2018, because what we saw a pattern where the initial lava that was coming out wasn't very vigorous. It was and the chemistry showed that this was old lava that was kind of stored within the rift zone under the surface, and these old pockets of magma that was cooler, it's more viscous, kind of sticky, and that's why it wasn't all that vigorous in the opening 2 weeks or so. But then within 2 weeks or so, fresh lava was kind of moving, magma was kind of moving into the system. It was much hotter, more fluid, and that's what caused some of those very destructive flows that I showed in the earlier slides. So the sampling, the geochemistry, the chemistry of this lava was really the key to understanding this pattern of the eruption going from kind of low vigor to very high vigor. And the fact that we were tracking the chemistry on a daily basis meant that actually the geochemists were able to kind of more or less forecast when that change would occur, or at least anticipate that that change would occur soon. Okay, so that was, we talked about the Pu'o eruption, Summit eruption here, and then the Lower East Rift Zone eruption. And when we had that Lower East Rift Zone eruption in 2018, it drained magma from the main magma chamber is below the summit here, below the caldera. And it feeds magma via conduit along the rift zone to this Lower East Rift Zone eruption. This Lower East Rift Zone eruption was so voluminous that it drained magma from the summit magma chamber at a very high rate. It drained a lot of magma. What that did is it caused the caldera floor to drop, kind of collapse in and subside. And it dropped by more than 500 yards, which is a lot. And so what I'll be talking about is what happened after the 2018 eruption, after that big collapse event or collapse events at the summit. What happened is, here is actually Halemaʻumaʻu crater. It's It's much bigger, much deeper, totally collapsed around here. And what we saw about a year after the eruption, 2018 eruption end, is that water started to seep into the bottom. And this is the first time that a sizable body of water has been observed at the summit in over 200 years. And it was very clearly groundwater that was kind of seeping in. So basically that collapse was just so large that it kind of penetrated into below the groundwater table. And eventually, as things kind of cooled off over a year or so, the groundwater kind of seeped back in. And we were watching this water lake with great concern because there is a history at Kīlauea, at the summit, of magma interacting explosively with groundwater. And so here we have groundwater that's right at the surface. Perhaps that might make the summit more susceptible to explosive activity. I think that was a real concern at the time. So we're watching things very closely, and that was 2019 to 2020. And in December 2020, we actually had magma or lava return to the summit. Thankfully, it did not cause large-scale explosive activity. Basically, the lava poured into the bottom of the crater, boiled off that water lake within an hour and a half, and just started passively filling the bottom of the crater with lava from these new fissures. So here's Halemaʻumaʻu crater, and you can see the lava. This is the first morning of the eruption. Lava is just kind of passively filling that. Thankfully, no explosive activity, or at least large-scale explosive activity. Okay, so we have a thermal camera that's on the rim, and it provides a very nice view of kind of what parts of the lake in that eruption were active and inactive. And here's the vent on the west side of the lake, and you can kind of see pretty rapidly that the eastern part of that lake kind of solidifies, and you're just left with liquid fluid lava on the surface on the western portion. Sometimes a little bit of it oozes out on the margins, but it's mostly limited to the west side. And the fact that the lava, became limited to the west side was kind of a testament to the fact that the eruption rates were kind of gradually decreasing through time. And eventually they reached a level where they just kind of dropped, and the eruption ended in May of 2021. So that eruption went from December 2020 to May 2021, about 6 months. After May, there was a few months of quiet at the summit. And then we had another eruption at the summit. That one started in late September of 2021, and it's going on today as I speak in January of 2022. And it opened, the main vent is also on the west side of the crater here, and it's basically just adding more lava to Halemaʻumaʻu. You also get a sense of how big that 2018 collapse was here. But these two eruptions that we've had over the past year are really, I think, a testament to the fact that Kilauea goes through these cycles where the summit will collapse, create a big depression, and then it will refill with lava. So we had the big collapse in 2018, created the large summit depression, and now it seems like we're in this kind of refilling phase of that collapse. Okay, so this new eruption that began in September 2021, a few months ago, it's still ongoing, and this is showing one of the first nights of the eruption when the fountaining was more vigorous than it is today. It's definitely more subdued, but the fountain here is pretty high, up to 50 yards or so. It's coming through the center of the lake here. Here's another time-lapse, thermal time-lapse of the new eruption, or the current eruption, filling in the crater more, raising the level of lava in the crater. It's almost to the rim here in this first kind of downdrop block. We have these islands that are actually kind of being lifted up. And we have the vent activity focused on the west side again. And again, as the eruption rates are kind of decreasing, the lava is kind of becoming, once again, kind of limited to the western side of the lake, just like we saw in the eruption from earlier last year. So, like I said, this eruption is still ongoing. You can come into the Hawaiiʻi Volcanoes National Park and actually see the lava from a lava viewing area. And just want to say thank you. And here is the web page for HVO, and here's an email if you have any questions. So I just want to thank you again.
All right, Dane. Well, that concludes Matt's talk there, and we do have some other Volcano Watch talks, or I'm sorry, Volcano Awareness Month talks we're going to bring to you guys.
Right.
There's one we're going to do next week that's relating to how HVO has been, I suppose, recovering from the 2018 eruption as well, right? And we'll pair that with a survey that's coming out for the national park that we'll discuss that in more detail next week as well, right? Seeking community input. There's some public meetings. There's online forums and all that. So if you guys want to look into that ahead of time, I think Dean will drop the link.
Yep, I'm dropping it now.
But otherwise, we'll come back to that next week. And then we also still have some Volcano Awareness Month talks on Maunaloa that we will discuss as well at a future time. Before we jump into the questions on Matt's talk, anything like that, I just want to add one more thing here, and let me. I think I gotta switch our view here. Here we go. This is a tweet by Cosme648333127. The final phase of pool eruption in Hawaii. This is a time lapse from 2014 to 18 using Sentinel satellite, which is here. So here it is. There it goes. All right, so you can see here, scroll up, the evolution of flow field. The pool itself is right here. And this is the Powell crater side over here. And the lava flows mostly went down this direction to Kalapana. But there was a period of time when it actually broke out and started going on the north side of the zone. And it was during one of those phases that it actually found a crack system over here, and this is what led it towards Pahoa for the Pahoa lava crisis 2014 and 15. So you see that track showing here on this as well. Otherwise, you see it could build up on this upper Pali area between the rift zone and the coast, and you see other areas of buildup as that flow once again spills back to the north. That's the little incident in the pool area I thought I'd throw in here, as that was part of what was discussed as well. What we got, Dane?
Yeah, so we have a $35 donation from our longtime supporter Gary Bryan, who says, "Thanks, Phil and Dane, for these updates. Appreciate the support, Gary, as always." Yeah, definitely. That was interesting, the stuff Matt was going through. I was kind of hoping to see more footage that we hadn't seen before. But, you know, there's a lot of footage out there, and we've been doing that. I've been doing that Drones On series to try and, you know, highlight some of the archive that's been released over the couple years since the eruption took place. Many of us saw clips like some of the ones that he showed there, some of the photos, because they were kind of the photos that we all saw as it was happening.
Mm-hmm.
But, you know, there's a lot of stuff that is less seen and equally important, but also just gives you that a complete different look at something that you'd only had a certain amount of fixed positions to show it. So that's always interesting, just to see that kind of footage. Would like to see that one, the unedited version, the full version of the lava coming through Kaupili Street in Leilani Estates, that footage that we were looking at there. I assume that it's cut because the camera work is handheld and there's people talking, so it's probably spinning around and all kinds of stuff. But, you know, it'd still be interesting to just see all that in the unedited form. Might be worth me reaching out to them on that.
Yeah, let us know how that goes, and that way anyone else who might have similar interests might know.
Right.
For sure.
So yeah, definitely interesting stuff, and it's just amazing to see the lava lake in 3 years go from lava lake to water lake back to lava lake, in completely different type of lava lake, but still the same type of lava lake. You know what I mean? Just interesting to see how fast Kilauea moves compared to the geologic time that you would see everywhere else on the planet.
Yeah, the last 10 years have really been a whole smorgasbord of activity, really. Like, you know, it's all different, you know, everything happening in a short period of time. It's really been an epic period to witness and part of here. Yeah, for sure. Yeah.
Right.
Yeah.
Some
Interesting.
people
Go ahead.
some people were talking about in chat, just like, what it would be like standing there just watching the fissure, knowing that it's probably coming right, in front of you, and why, they don't run away or anything like that. And, it comes from experiences, is what I was saying, that people have grown up on this volcano and knowing nothing but eruption, right? Knowing nothing but the lava coming down towards their homes or threatening a community nearby, stuff like that. And they've gone through, the ups and the downs for years. So the comfort level that some people have on Kilauea compared to the assumptions that people might make that don't have experience on it is a vast difference. Like, it's a huge polarized difference, just between people that moved here recently and people that grew up here their whole lives, say in Kalapana.
For sure. Yeah, it's different when you're in it. I mean, that's easiest thing to say and the hardest thing to explain, really, right? Because there are so many other things pulling, right? You know whose homes those are, and you want to see what happens because maybe they asked you, or you need to tell them, or that there is an animal missing somewhere nearby, and so keeping an eye out for the animal and like looking for the animal to run out of the house or out of the bushes, or there's all kinds of other things, other stories that we've covered exhaustively in the past, and I don't have to dive into all of it here, since we're picking at the scab a little bit. But really interesting to see those new perspectives there, yeah, for sure. And yeah, I mean, what I was going to say connects to what we were talking about earlier today was this whole gas-rich lava versus not gas-rich lava, right? We have an example of the first lava coming out being that gas-poor lava that's been sitting under Leilani for a long time, that first video of 2018, right? We have video of gas-rich lava at Halemaʻumaʻu before that, and gas-rich lava afterwards at Halemaʻumaʻu. So that, for the question that was asked earlier, that's an illustration of those different kinds of gassy magma there, right? So that was cool to look at that. And he also mentioned something we talked about today, the bubbling at the edges of the lava lake, and how it can pull lava towards it, right, by falling into that hole that's formed by the bubbles, right? That was cool to hear him explain. Did it much better than I. Try to recap it right there. And then same thing we've been talking about, the ground tilt and lava lake levels getting tied together 1-to-1, right? We had a simpler version of that in 2008 to 18 that he showed in that video. He showed the time lapse of the lava lake rising and falling, and a tilt and the ground tilt and the lava lake level rising and falling in pattern, right? And that's exactly the same thing we see today, with the added complication of the nozzle close at the top, and then we have a pause, and so it stops on top of that with that little slight delay from that whole process of the surface. Whereas before it was open all the time, and it was just plain and simple up and down, and that was all there was to it. Simple case, and now we have a slightly more evolved, complicated case. That was cool to see too.
There was one little thing that he mentioned that just kind of blew my mind a little bit, because I never thought of it, was when the video out on Kapili Street and the steam's coming up and all that, the beeping sound. I just assumed that was some sensor that they had on them, and that they disabled it after that first day because it was annoying as hell. And, something along those lines. It was some device that they were carrying. But then he says that it was the fire alarms inside the house. And it's like, oh, man. Like, I didn't think that those were the fire alarms from the house. Like, those things were, blaring. Okay, that's why there's so many of them going off. Okay, like, I get it now. But before that camera turn happens, right? You didn't know how much smoke was going in there exactly at that point in time, right? It could have been just the same as on the road that you were seeing, but instead it was heavy, thick, blacker smoke in there.
Ooh, yeah, intense. Yeah, you hear every single house's fire alarm as it burns down, right? That was an intense.
Yeah.
Yeah, I was only there for small moments of it. Any one of us, small moments. Some of us more than others, but still, any one of them on its own, pretty super intense.
Right.
Happened hundreds and hundreds of times.
Oh yeah, and lots of little stories like that. All kinds of little stories, people trying to get back in and stuff like that to get their belongings out even while it's erupting. I know the guy on the opposite side of the street, the lava during the like there was some really bad cracks and stuff through the yard, but he was still trying to evacuate stuff, and they were putting like plywood down over the cracks to be able to try and get the truck in there, stuff like that. That's just the things that when you're there that you don't even think about. You're just like, all right, we're doing this now. We're going. And that's just like the mentality sometimes. But there are people though that I knew one guy that the eruption started. He was in Leilani Estate. Hilo was not far enough. He drove all the way to Kona. Right. So there's difference on the spectrum there.
Yeah, so we could tell stories all night long here. Go check out Dane's Drones On series if you want a full recap and insight from his perspective as a resident of everything that went on there. So we'll point you guys towards that, and if you haven't seen it yet, or if it's been a while, this is on your mind now, you want to check it out again, then go and do that over there. Yeah, we'll close our 2018 discussion for now. Anything else on this video of maths, or should we wrap it up here? And
I think that's good.
All right.
I think I'm got everything out I need to talk about. So pass it back to you.
Yeah, sounds good. Yeah, so mahalo to everyone who supported us, contributed, commented in the chat. I see we've had over 100 messages through our chat here today. A little alert told me that. So mahalo you guys for engaging with us. If we missed your question, we'll try to get to it later. You can ping us, whatever else, and feel free to submit your pictures or videos of what you've seen on the volcano. We can do that. Start incorporating some more of those as we have as well. And unless something extreme happens between now and next week, we will just be back with you guys in 1 week. Oh, I did see one question pop up here, Dane. Maybe I should load this up here real quick just as one final point of comparison, right? A question here about how much did the ground inflate when those fissures broke out, right? So I have here a tilt plot from that eruption, and it's hard to zoom it in a lot, right? The blue line is a summit, and the green line is on the rift zone, right? So our unit on the side here, microradians. We're looking at inflations of 1 or 2 microradians nowadays at summit. You can see here this signal jumps from 300 to 800 and then drops down to 0. So we're talking about a variation of close to 1,000 microradians there. We're normally looking at 1,000th of that now day to day here in Kilauea. It went up 1, it went down 1. It's a pause. It's not a pause. So when these things happen, they're obvious, and no sign of anything like that happening now. So maybe that's the best place to close it off, is no sign of anything like that happening right now again. Until next week, you guys, from HawaiiTracker.com, he's Dane DuPont, Philip Ong.